Hi, I'm Kedan. I'm presenting our work controlling virtual Tron pipelines through rendering policies. This is a joint work with Jeffrey Zhang, Shao-Yu Chang, and David Forsyth. So there's many ways you could style the same outfit, even if it's just a simple pair of shirt and jeans. And the key challenge here, there's a couple. So number one, we only want to modify how the garment is worn without changing the garment property. So there are other works that also modify how the garment is dressed, but they happen to change the garment itself. So we're trying to avoid that. And we also want the control to be intuitive, such that people without technical knowledge, such as a stylist or a quality worker, can also use our control method to change the outfit. And at last, we also want the system to be scalable, such that when we apply change, when we make change to one kind of outfit, we could also apply to the other garment of the same type. So the first important choice we have to make is the medium of control. So we need something that can represent garment drape and are fairly easy to manipulate. So we end up deciding to use key points with garment semantic as the control points. So for example, here, we've used the pre-trained key point predictor model from Deep Fashion 2 to predict the garment key points on our training data. And you can see between those images, the key points of the same color has the same semantic meaning, such as shoulder or like neckline, you could see them having the same color. So having this garment semantic is really important because it helps us scale the control. For example, if I figure out how to adjust one set of control points on a garment, then I could also apply it to other garment of the same type because all the control point has the same semantic. So the way we actually control the warp using the control point is by training the warper condition on those control points. So once we've done that, during inference, we can adjust the control points and the garment would drape accordingly. So here you could see on the right side, we've done a little interpolation where we move the inner key points of the outerwear further away to simulate a outerwear being dressed more loosely. And we could see the warp follow the control point very closely. Given the control point, we have to redesign our inference pipeline to incorporate them. First, you still have the set of garments and the model. We would first predict the garment control points for all garments based on the natural garment image and the body pose, and plus another class which specify which set of points we should predict. So for example, if you have an outerwear, you can predict a set where the outerwear is open versus closed, and they would control by a class. And say if I have a style template, I can then apply it to modify my control points. So for example, in the earlier examples, we want to make the outerwear split a bit wider. So here we would apply a little heuristic to move the control points towards the outside by a certain offset. And once I'm done manipulating my control points, I would predict the warp for each garment based on my final set of control points. So if we look at the training pipeline, we have three components here. So yeah, we first train a regressor to predict the control points of the garments on a person. So the regressor would take the body pose and the neutral garment and spit out a bunch of coordinates. Then we train the semantic layout generator to, based on the control points, predict the semantic layout. And finally, we train a warper/image generator to produce the image. And we also feed in the control point as reference to guide the warper. So now that we have the framework, how do we actually control how a outfit would drape? So if you look at this example here, there's a little artifact in the region. And that's kind of because we use control points of garments to decide where the garment goes. And the control points of the coat and the skirt are predicted separately. So if the skirt is beneath the coat, then there's a chance that the skirt actually sticks out of the coat. So in this case, we can write a simple rule that applies to the offset of the garment, where in the example, we would draw a line for the skirt and for the outskirt of the coat. And we check if the skirt control point is inside the coat. If not, we simply just shift it in. So if you think about it, this also gives us a very intuitive way to control, or to construct a policy to do many kind of things. So for example, if you want to, you can change a single garment by moving the control point, such as changing how wide a jacket would open. You could do some interaction between the garment and the person, such as deciding how high the waistline should be. Or you could do something between multiple garments, such as the one we did between the skirt and the coat. So we've done some evaluation to see how well our system generalized. In this evaluation, our goal is to make the garments in an outfit coordinate well. So we sit down with 20 outfit example as training set. And we wrote 27 little piece of rules such that all the outfit looks good. And then we apply these same rules to a bunch of randomly sampled outfit, which we use as test set. And we see how well the set of rules would generalize on the test set. So here you see are the examples where you can see without the coordination, if we throw a bunch of garments, then there's a ton of artifacts on it. And once we apply our heuristic, then all of them looks fairly clean, which means the system is able to sort of generalize to more examples, even though it's only constructed using a small number of examples. And we've also done some quantitative evaluation for this. The way we did that is we randomly sample a large amount of outfit with different numbers of items. Then we ask different Virtuotron system to render the same set of sampled outfit and compute FID score against a data set of real outfit image. So the smaller number means that the distribution of the generated outfit is closer to the real outfit, which is what we would like to see. And from the results, you can see that our method outperforms two baseline. And there's also a consistent improvement by adopting the rendering policy we just came up with, which also shows the rendering policy generalized well. And you can also see as the number of items increase in the outfit, the score becomes bigger, which means the outfit has just become harder to manage. We can also use the same system to build templates that would render the same outfit in different ways.
Okay.
So like the way we would do that is you can have a stylist to start creating a style by dragging the control points around and changing the drape of one example until they're happy. And then the style can be implemented into some simple heuristic to modify the control points of the garment at scale. And then we apply the scale to, we can apply the style to the other garment of the same category because the control point had the same semantic. And on the right, you could see like the examples where we are changing, we define a couple style for how we want to drape the outerwear. And those are examples that when we apply those rules to different outfit, you can see all the outerwear sort of drape in the same fashion, despite the rest of the outfit are different. And the garments are also different. Some of them are longer, some of them are shorter. Yeah, and there's more examples for how we can dress a shirt between a shirt and the pants. So for example, here, if you want to tuck in the shirt, you would narrow the control points at the waist for the top, such that it becomes more narrow than the control points for the pants, and you render the pants on top. So you get that effect.